There are lots of problems involving percents. Most of the time when I encounter problems with percents, I've always used one equation that's always helped me out, this one concept, and that's percent times a number gives you that percent of that number. For example, if you're in a situation where you need to know, say, 80% of 75, so we want 80% of 75, what you have to do is you just take 0.8 times 75, and that gives you 60. So in this way, we would say that 80% of 75 is 60. Every single problem that I know that involves where you know the percent that you're dealing with can always be solved this way. Also in my head, I have a little visual that goes along with this. So it's always like this. You're taking some number and you're multiplying it by some percent, and it's going to modify that number either up or down to give you a new number. The way that I look at this is the old number I always represent by a vertical bar like this, and after I multiply by some percent, it's either going to get larger or smaller. So let's take this case here where I wanted 80% of 75. This number is going to be translated into a smaller number. All right. The visual that goes along with this is you have to see this, since this represents the old number, the 75. This length here, the length from top to bottom, represents 100%. Right? If I multiplied by 100% or 1, the result over here would be a bar that was exactly as long. But so this is 100%, but that's not the case here. We're actually getting a smaller number. We're getting 80% of this. So what's going on is the way that I represent that is this difference here. This difference here is 20%. All right, 20%. So to get from this side to this side, we want like this much of it. 80%. 80% is this. And so when we multiply by 0.8, the portion that gets carried over is only 80% of the old number. See, it's not quite as long. So 0.8 times the old number gives a number of new length, of new size. To carry it out, you would just say that's like 0.8 times 75 is smaller number 60. And that's if you want to make a number that's smaller. If we take a number, say this, doesn't matter what it is. Let's say that I want to increase this quantity by 30%. All right, so this is going to turn into a new number that's going to be larger. How much larger? 30% larger. So the visual that you get with this is this. This length still represents 100%. Alright, so that's 1. Multiplying by 1 gives me, would go across and give me something exactly that tall. But the thing is getting larger by 30%. So this here, 30, represents the amount of increase. So to get there, what we do is we take the old number, the 100%, plus 30%, and we multiply by 1.3. So the old number, whatever that is, I call it, just symbolize it as that, 1.3, 100% plus 30%, is, when multiplied, is going to give you whatever that new thing is. So for example, if the number that I started with was, say, 83, and I want to increase that by 30%, I multiply 1.3 times 83, and that gives me 107.9. Alright, it should make sense that the bigger number has to be bigger. It should make sense that the end result has to be bigger. But this is how I see all these problems. I see there's some number out there, and you're multiplying it by a number that's either greater than or less than 1. Alright, if you're multiplying by a number that's less than 1, the result is going to be smaller by whatever percent drop it is. Right? And if you multiply by a number greater than 1, the result is going to be larger by whatever the percent difference is. Now, these problems, they all come down to four basic things. All right, either increases or decreases, and whether you know the before number or the final number. Just to give a simple example, we'll do one with sales tax. Say, suppose that you have an LCD TV whose the price on the shelf is $699.99, and you know that there's 7% sales tax on top of that. So the final price of the TV is going to be $699.99 plus an additional 7% of $699.99. Now the way that lots of people want to do this at first is find 7% of $699.99 and then add it to this. And that's fine. To show how that would go, let me just draw it out for you. This would be the original $699.99. Now we want to compute 7% of this number. 7% of it. So we only want like a really tiny amount. It's going to drop by this big amount, 7%, 93%. Okay, we only want 7% of this. So this is the number we're going to multiply by. Here's your 7%. So 0.07 times $699.99 is going to give you the smaller portion of it, which is $48.99. And you want to take that $48.99 and add it to the original $699.99, and when you do that, you'll get $748.49. Now that's kind of a roundabout way of doing this. If you look at this in a better way, you could do this a little bit faster. The original price is $699.99. Now the price that you're going to pay is going to be a modified version of that. It's going to be, in fact, 7% higher than what that number is. So you're going from a smaller number to a larger number. So we can get this all taken care of in one hit. If this length represents 100%, we're looking for a 7% increase. So this is the amount by which it's going to go up. There's your 7%, and this is the 100. So what you want is, this number, the final number, is going to be 107% of the old number. So that's how you figure out what to multiply by. It's going to be 1.07 times the $699.99. And if you do that directly, you will get your $748.49. Right? Only have to do it in one step, so you don't have to find what the percent increase is and then add it back to the original. You can take care of it all in one hit by just realizing that what you're doing is increasing some number, multiplying it by a number that's larger than 1 to get the final number that you want. Now you got to be careful here. Before I move on, I do want to point out that if you take a number and you add a certain percentage to it, and then you take that same percentage away, you do not get the original number back. For example, let's say I want to take a number like, doesn't matter what it is, I'll say, just to keep it easy, I'll say 100. If I want to take this 100 and I want to add, I'll say add, say 30%. If I take 100 and I add 30% to it, I'm multiplying 100 by 1.3, and that gives me 130. Okay, so I took 100, added 30%, got 130. If I take 130 and I take away 30% of that, I do not get 100 back. This is how we do decreases. Okay, I'm going to take, I'll take the 130, and I want to take 30% away from this. So I'm going to wind up with a smaller number, a number that's smaller by 30%. So let me just draw this out. The original thing, here's 100%. We're decreasing this by 30%. So we're taking away this amount. All right, 30%. So what's left is the remainder is 70%. So this is the number that I multiply by to translate it straight across to get this. If I'm taking away 30%, I'm actually going for I'm actually finding 70%. So to take away 30%, we actually have to multiply by sort of the complement of 30, whatever complements it to add up to 100%. So to take away 30%, I multiply 0.7 times 130, and that gives me 91. So look at what happened, right? I took 100%. I took 100. If I added 30% on, I got 130. If I took that 130 and subtracted 30% from it, which is multiplying by 0.7, I get a different number. So this is something that pops up over and over and over again. When you're trying to take away a percentage, you don't actually subtract anything. You're multiplying by a complementary number. All right? Just like when you're adding a certain percentage, you don't actually have to add anything in. You just multiply through by something, and it takes care of it all in one hit. Now, there are basically four types of these problems. Whether the number that you're dealing with is increasing or decreasing, and whether you have the before number or the after number. So if you look at the problems that are written in the description, I'm gonna go through those now. Number 1 says that the manufacturer of a tablet PC claims that next year's model will be 13% lighter than this year's model, which weighs 30 ounces. So how much is next year's model projected to weigh? So, all right. What you want to notice is what's relevant here is 13% lighter. That means a 13% decrease. Okay, so there's some number that's going to go down by 13%. So which number are we given? Are we given the before number or the after number? If you think about it, we're given the before number because it says that the one, right now it weighs 30 ounces and it's going to undergo a 13% decrease. So this represents, the before number represents 30 ounces. Let me write that in black. 30 ounces, and it's going to drop by 13% to something new. Once again, I come over here with my numbers here. I say this represents 1. If I multiplied 30 by 1, I would get 30. But I don't want to do that. I want to multiply by something that represents a decrease in 13%. So I'm taking away this much of it. So this is 13. The remainder is going to be 87. So actually, when I say that the 30 ounces is going to decrease by 13%, I'm saying that the result is going to be 87% of the original 30. And that's how you have to translate it. All right. Once you figure out that what you really want is 87% of the number that you're given, the problem goes pretty easy, because all that you have to do is say 0.87 multiplied by 30 ounces. You work that out, you get 26.1 ounces. It makes sense, right? It's lower, and it's lower by maybe not that much. We went from 30 to 26.1, so this number does seem reasonable. So that's if you know the before number and it's a decrease. For the second problem, it's still going to be a decrease, but we're given the result. All right, it says due to a rapid shift in demand, the price of gas declines by 9%. So something is decreasing by 9%. There's a 9% loss in there someplace. To $3.47 a gallon. So that means that this result is $3.47. So some number, some original, and then what was the price before the shift in demand? So there's the old price when multiplied by something gives you $3.47. Now, what did it say? It said that it declined 9%. So that this length here represents a 9% drop. So if the whole length is 100%, you would recognize this as being, oh, okay, the new number is going to be, the complement of 9 is 91%. 91%. 91% of the old number is going to be $3.47. So all that you got to do in this case is just set it up. 0.91 times the number that you want equals 347. So to get the old number, x is 347 divided by 0.91, and when you work that out, you get 381. All right, $3.81. You could do a quick check just to see if you multiply 381 by 91% or 0.91, you will get 347. So that's how you do it if you know the result. So it really just kind of depends on you have to recognize a decrease as multiplying by not the number that they gave you, but its complementary number, right? A drop in 13% is really finding 87% of something. A drop of 9% is really finding 91% of something. So those are decreases, and that pretty much tells the entire story. The third one has an increase where you want the, well, let's see, it says the price of the stock is $43 per share. And market analysis anticipates that there will be a 12% rise in the stock over the price of the next month. So that implies that the final number that you're going to get is larger by 12%. What does she predict that the price of the commodity will be next month? So this is where you want the final answer. All right, the original thing is $43, and you have to see this as a gain of 12%. Right, gain of 12%. So that's 12, and this is the original one. So when we multiply this number by a number that's larger than 1, the answer is going to get bigger. So we take the 100%. To it, add the 12%. So that's 1.12 times 43 gives you is going to give you what the predicted price is. And when you work through that, 1.12 times 43 gives you 48.16. 48.16 is what the predicted price will be. Just to show you that a 12% increase and a 12% decrease are not the same. Really quickly, I want to take 12% away from 48.16. So I'll do a little problem in here. Let's say that this is the 48.16 number. If I want to reduce this by 12%, right? Reduce this by 12%. Then what I really want is to find 88% of this, the complement. 88%. So I take, and that's going to, right, let me just write this. So that'll give me a new number. So to take away 12% is really to multiply by 88%. And 88% of 48.16 is 42.38. So notice it's somewhat close to, but not exactly equal to, the old number, right? You take 43, add 12% by multiplying by 1.12, that gives you this. And if you take away 12% from this number, you multiply this by 0.88, and that gives you 42.38. The reason that this is different is because when you add some percent and then you take a new percent away, you're not dealing with the same number that you were just dealing with, right? 12% of this number is less than 12% of the new number. Finally, the last example I have is that after a 15% Canadian sales tax is added, the bill for a motel room, it comes to $138 for one night. And what was the advertised pre-tax price of the room? So that's an increase, right? There was some number, 15% was added, and the outcome was 138. So recognize this as an increase. It'll be something like this. Now, which number are you given, the old or the new? You're given the 138. All right, and the old number, it says, since 15% sales tax was added on, that represents a rise in 15%. 15%. So when you add that to the old 100%, what you're going to come up with is 115%, which is 1.15, multiplied by the old room price, gives you the new room price, the 138. So you have the final thing. So once you know how to set it up, all you have to do is divide through, right? You'll get x equals 138 divided by 1.15. And when you do that, you should get a smaller number, and you do. You get $120 was the advertised price. So that's pretty much it. That's how all these problems go. There's a before number, right? There's a before number, and you're going to multiply by some percentage. Let's say if you're multiplying by something smaller, say a drop in 20%, right? 20% drop actually represents 80% of what the old number was, and you're going to get from that the new number that's not quite as big. So to represent a drop, say in 20%, you would multiply by 0.8. So that'd be 0.8 times the old number equals the new number. And if something is being increased, then the old number represented by this, it's going to go to a bigger number. So what do you multiply by? The percent increase. Let's say that we're increasing something by, I don't know, 50%, say. To increase a number by 50%, you take, here's the original 1. Alright, always represents, that's 100%. Plus the 50% gives you 1.5 times the old number equals the new number. And that's pretty much the way all of these problems go when you know what the percent increase or decrease is, and you either need the before number or the after number.